Today we're going to learn about how to use determinants to help us to solve systems of equations. Last time in 12.2 we were using row operations to help us solve. Today we're going to learn a different way. But before we actually try to solve some using determinants, we need to figure out what a determinant even is. So the first thing I want to do is work with a 2 by 2 determinant. So we're going to use basically the x and the y column of a matrix to help us evaluate a number that we can use to later solve. So I'm going to start out with the matrix 8, -3, 4, and 2. And I want to evaluate the determinant of this matrix. The way I'm going to do that is I'm going to take the diagonal of the 8 and 2, and then I'm going to subtract the diagonal of the 4 and the -3. So if I multiply the 8 and the 2, that'll give me 16, and I want to subtract from that a -3 multiplied by the 4. So I end up getting 16 plus 12, which is 28. So the determinant of this matrix would be 28. And we'll learn later on in the lesson how we can use that to help us solve for x or y. Let's try another one. If I have a matrix 1, 7, -2, -1, and I want to find the value of the determinant, I'm first going to multiply the diagonal with the 1 and the -1. Then I'm going to multiply the diagonal with the 7 and the -2, and then subtract those two products. So if I multiply the 1 and -1 and subtract that by 7 times -2, the value of that is going to equal -1 plus 14. So the value of this determinant would end up being 13. So we can evaluate these determinants with 2 by 2s just by taking the product of each diagonal and then subtracting those two products. And in doing so, we can be able to use that to help us solve for x and y later. Now, before we solve for x and y in an actual system, we want to know how to determine what the value of a 3 by 3 determinant is. So I'm going to set up my 3 by 3 determinant. I'm going to take 4, -1, and +2 as my top row, 6, -1, and 0 as my middle row, and then 1, -3, and +4 as my bottom row. The way we can evaluate a 3 by 3 determinant is by breaking it up into a series of smaller 2 by 2 determinants. And what we want to do is choose either the first row or the first column of numbers in our matrix to help us do that. I'm going to select the top row as the expanding row that I'm going to use in my determinant. So what I need to do is take each of those values and put it in front of a 2 by 2 determinant. So I'm going to have 4 times the determinant of something that we'll talk about here in a second. I will have the opposite of the 1, so I'm going to say +1 times the determinant of something else, and then keep the sign on the 2 and have a determinant here. When we expand it, those coefficients of 4, -1, and 2, the first coefficient, in this case the 4, will keep its sign. The second coefficient, the -1, is going to switch signs. And the last coefficient of 2 is going to keep its sign. So anytime we're expanding, we want to keep the sign of the first term, switch the sign of the second term, and keep the sign of the last term. Now, when I am determining what I'm going to put in each one of these 2 by 2 determinants, I'm going to look back at my 3 by 3. So if I look at the column that the 4 was in and the row that the 4 was in, I'm going to eliminate those and just use the values that are left over, the -1, 0, -3, and +4 as the 2 by 2 determinant, what goes inside of there. So I'm going to put the -1, 0, -3, and +4 as the 2 by 2 determinant. when I look at putting numbers inside of the next 2 by 2 determinant, I want to eliminate the column and the row that the -1 was in and take the 6, 0, 1, and 4 that's left over and put those as the 2 by 2 determinant for that second one. And then I can do the same thing with the +2. Eliminate the row and column that +2 are in, and what I'm left with is 6, -1, 1, -3 for that 2 by 2 determinant. And at this point, I have 3 2 by 2 determinants that I need to figure out what their values are. And when I do that, I can then take the sum of all 3 of those, and I will have the determinant of my 3 by 3 matrix. So in order to do this, I'm going to say I have 4 times. If I take the product of -1 and 4, that's going to give me -4. And I want to subtract the product of 0 and -3, which is 0. Then I'm going to add 1 times the determinant of this next 2 by 2. 6 times the 4 gives me 24. And then subtract the product of 0 and 1, which is 0. And finally, I'm going to add the 2 multiplied by its determinant. 6 times -3 is -18. And I will subtract the product of 1 and -1, which is -1. So simplifying these terms, I end up getting, let me change the color here. I have a -4 inside this first parenthesis. I have a 24 on the second one. And a -18 minus a -1 is going to give me -17. So if I want to continue this, 4 times the -4 will give me a -16. 1 times 24 is going to give me 24. And then 2 times -17 will be a -34. And if I add those together, -16 plus 24 gives me a +8. And +8 minus 34 is going to give me a -26. So as we see, we've broken it down into a series of 2 by 2 determinants where we can evaluate each one of those. And as we take the sum of those determinants, we are able to find the value of that 3 by 3 determinant, which is -26.